So, we are discussing the issues related to snowball Earth, and the issue was if the oceans did indeed freeze to the equator, where did surface life survive, because you need life on the surface for photosynthesis. So, people thought it could be at some geothermal hotspots, because there is a lot of heat inside the earth due to radioactivity. If that heat comes near the surface and melts the ice slightly, there will be pools in which if the thickness of sea ice is not very large, it will be transparent. So, some life will survive. If some parts of the tropical ocean are not frozen, of course, that will be good. Or in water-filled crevasses at margins where the ice is broken up, there can be cracks in which life can grow. Now, this is based on the experience of people who have gone to the ice sheets and glaciers in the polar regions. They find that wherever there are crevasses, cracks in the ice, life survives. Okay? So, life is very, very tough. It can survive under very adverse conditions. Okay? So, this is also possible, and of course, if there is a thin ice and radiation can go through. So, one need not worry about it as long as there is some small region near the tropics where solar radiation can reach and allow photosynthesis. Now, how does Earth escape snowball Earth? Okay? Because CO2 will rise slowly because of volcanic eruption, and once the CO2 rises, greenhouse effect will increase, and once the melting point of ice is reached, that area will not allow ice growth, and once melting starts, albedo will start reducing, okay? And the dark water in the ocean along with high CO2 will result in very fast melting. So, under this condition, global sea ice even 300 to 400 meters thick will disappear in a matter of 100 to 1000 years before CO2 can reduce. Okay? So, this is the based on models. So, we know that after the snowball Earth has formed, because of the volcanic eruptions, CO2 will build up and it can melt a 300-400 meters thick ice sheet in a matter of 100 to 1000 years. Okay? This is called transient ultra greenhouse effect, because at this time the CO2 content is very, very large, much larger than what you are today. So, Earth will very soon reach the ice free branch, will jump from ice cover to ice free. Okay? And estimated surface temperature in the tropics when this happens will be around 40 to 50 degrees centigrade. Okay? So, from snowball Earth we will jump to what is called hothouse Earth, very hot temperatures. Okay? So, there will be a lot of water vapor in the atmosphere now, because temperature is very high, and rain will keep pouring down and it will start weathering the rocks and will bring down CO2. Okay? So, this is a situation which occurred at the end of the last snowball Earth event. Okay? So, the standard silicate weathering cycle will operate at very rapid rate, because carbon dioxide is very, very high, rainfall is high, it combines with calcium silicate to form calcium carbonate. Okay? So, CO2 has to dissolve in water to do that, because it has to form carbonic acid, and that acid will react with calcium silicate to produce calcium carbonate. Okay? So, this calcium carbonate which forms ultimately settles down at the bottom of the ocean, and today we can see those calcium carbonate layer, the so-called cap carbonates, which occurred after the snowball earth. So this was the major evidence for people to believe that snowball earth had occurred, because immediately after the evidence of rocks containing glacier signatures is this layer of cap carbonate, which sits right on top of the rocks which show evidence of glacial striations or marks. Okay? So this is what convinced most people that snowball earth had occurred. Okay? So here you are talking about long-term carbon cycle, which we normally cannot understand because human life is around 100 years and these operate in 100,000 to million year cycle. Okay? Where carbon dioxide is added through volcanic activity, rain brings down carbon dioxide into the ocean, forming carbonate sediments, limestones, and plate tectonics causes the sediments heat up, releases CO2, and that CO2 comes into the atmosphere through the volcanoes. Okay? So that is the cycle which has operated for Earth to come out of the snowball Earth to the present climate. Okay? So volcanoes source of carbon dioxide, they control surface temperature and hydrological cycle. Surface temperature and river runoff control weathering rate of silicates. Silicate weathering is a sink for CO2 and it was the ocean, and since CO2 decreases, temperature decreases. You can see a very nice thermostat here which operates where CO2 controls temperature. The amount of CO2 is controlled due to balance between volcanic eruption and weathering. Okay? So this is how the temperature of the earth fluctuated for a long time before human beings interfered with the cycle and introduced carbon dioxide through fossil fuel emissions, okay, which are not a part of the regular climate system. So the reason why this has happened is volcanoes don't care at all about surface temperature. Volcanic eruption occurs due to plate tectonics. It is independent of the surface temperature. It depends on conditions occurring deep inside the earth where there is molten lava whose temperature is controlled by radioactivity, not by the sun's radiation. So all these models show that snowball earth will be there only for a short time, maybe a few million years, because of volcanic eruption. So this is a summary of what Hoffman and Schrag wrote more than 24 years ago in Scientific American. I would recommend this paper. It's written well. It's a popular article for people to understand snowball earth. Okay. Now, the evidence of snowball earth is now can be seen near roadside in Canada. Okay. Right on the roadside in Canada, you have this glacial diamicetite, which are rocks which are pulverized by glaciers right here, very small pieces. So looking at those pieces, you know something had ground that rock into small pieces. Just above that is the cap carbonate, calcium carbonate layer, which was formed after the snowball earth ended and carbon dioxide became very high in the atmosphere, and it caused weathering and increase in rainfall and hence deposit of calcium carbonate in the ocean. Okay? So these two occurring next to each other is the proof which convinced many skeptics that this had occurred. Now, how do you know the exact age which occurred? We are lucky there was a major volcanic eruption around 635 million years ago. The ash released by that volcano is recorded here. Okay. So, for geologists, ash layers are very, very important. They tell you the sequence of events occurring on Earth, because volcanic eruptions don't occur every day, they occur once in a while. I am talking about the big eruptions, and when they occur, they put a layer of ash on the surface of the Earth, which is ultimately washed into the ocean, compacted, and we can see today. So, we can see in the rock ash which was released by what eruption 635 million years ago. Okay. So, that is the beauty of work in geology, that we can understand the history of the Earth by looking at rocks which are formed millions of years ago and whose evidence is seen by the roadside. Okay. So, those of you who travel by road and see rocks, you should look at them and ask when were these rocks formed and what kind of rock they are, because they tell you the history of the Earth. So, the important thing about the snowball Earth hypothesis is that it also predicts that snowball Earth will be followed by a very warm Earth called the hothouse Earth, where the carbon dioxide would have been in the range of 20,000 to 90,000 ppm. Okay. So, that is required to melt all the ice. Okay. Now, here is one more example of calcium carbonate on top of the glacial diamesitite. Okay. In this case, there is a dolostone in Brazil. You can see a sharp change here. Normally in geology, everything changes slowly. Okay. All the changes are gradual. This is called uniform change. But now and then Earth has a dramatic change between snowball Earth and very warm Earth. So, this is the evidence which was collected by Hoffman, which ultimately convinced people. This evidence is available all over the world: Brazil, South Africa, Canada, and so many other places. Okay. So, people have argued that based on volcanism, that it will take around 4 million years for CO2 to build up to this kind of levels, 120,000 parts per million, in order to melt ice totally. Okay. So, under these conditions, when CO2 is very high, the landscape becomes a chemical reaction factory. Okay. Silicate weathering takes place very rapidly. Okay. And at the point where tropical oceans start to open up because the ice has melted, this ultra greenhouse effect will start the melting, but that will also begin the silicate weathering. Okay. So, all the changes that are occurring can be seen by geologists because they look at the carbon-13 isotope. Okay. So, the carbon-13 isotope in the deposits that we get today will vary a lot depending upon photosynthesis. Photosynthesis takes carbon dioxide from the atmosphere and fixes it in the leaves and the trees. While doing that, it prefers carbon-12 to carbon-13. Okay. So, carbon-13 is not easily taken out of the air into the leaves because it is heavier. Okay. Slight difference is there. That slight difference can be measured. So, this consequence of snowball Earth is documented in the changes in the isotope fraction, and this is shown here schematically that the carbon-13 isotope compared to a standard was quite high before the snowball Earth event, then it decreased rapidly, remained negative for about 10 million years when there was no photosynthesis. Okay? And when photosynthesis restarted, the carbon-13 isotope value started increasing again. Okay? So, this is the timeline as obtained from modeling based on rate of weathering and the rate of albedo change. Okay. Now, I wanted to see one important point about this model. When the snowball glaciation is about to start, the thickness of ice, okay, will this 50 meters of change in thickness is what you see here. Okay, 50 meters. I want to see carefully here. The change in thickness is 50 meters in 1 million years. Okay, in this period. Okay, but once the snowball glaciation is over, the buildup of the calcium carbonate layers is 40 meters in 1000 years. I want you to see the difference. This is every million years, this is every 1000 years. So, essentially, after the snowball glacier is completed, the deposition of calcium carbonate in the deep ocean will be around 1000 times faster. Okay? And that is documented in the data obtained by geologists. So, this hypothesis that when the snowball glaciation ends, there will be a super greenhouse effect and there will be very large amount of weathering, which will lead to deposit of rocks which is 1000 times faster than it was before. Okay? So, this is what convinced many people about the snowball Earth hypothesis. Okay? Again, this is a schematic showing how the surface temperature, which is around 15-18 degrees, gradually declined during the onset of snowball and then rapidly declined when the snow reached the equator. And then the temperature grew very slowly over 1 million to 10 million years as the carbon dioxide increased. And then once all the ice melted, it rapidly increased in temperature to 60 degrees centigrade. I wanted to see the number that after the end of the snowball, the Earth's temperature will be 60 degrees centigrade compared to 15 today. Okay? So, that is how dramatic events are after the end of the snowball. All these are documented in the rock deposits that are seen after the snowball Earth event. Okay? So, this is a theory which makes crazy predictions, but those predictions are supported by actual geological evidence. Without that, people would not have believed it. So, this is a cartoon showing from Hoffman's article in Scientific American how the Earth went from snowball Earth with high albedo and almost no greenhouse effect to a moist, hot greenhouse with a very low surface albedo, high flux, strong greenhouse effect and significant water vapor escape. Okay? So, this is the theory of how snowball ended. Okay? So, this can be understood through our energy balance model If CO2 increases, the radiative force into the CO2 will go up to 50 watts per meter squared, which is very large compared to 2.5 watts per meter squared we know that occurred in the last 150 years. Then it jumps to a ice-free state. Okay. It remains there for a long time. Then it comes back to the snow-covered earth. So this is a cycle that operated during the time. Okay. So this we had already discussed. There are some people who have challenged this theory. So people always have wondered how life survives on Earth. So recent polar biota shows that organisms have found ways of persisting on and around ice of the Antarctic continent through the last glacial maximum 20,000 years ago. So we are learning more and more about how life survives under cold conditions, because people are going to Arctic and Antarctic to get ice cores. During that time they are seeing life forms which you don't see in the rest of the earth. Okay. So the point is that the snowball earth hypothesis explains various extreme events that occurred in the history of the earth. One is the occurrence of dolostone or cap carbonates above the ice layer. Then the banded iron formation, which indicates that ocean had almost no oxygen for some time. Also from paleomagnetic evidence, which showed that rocks which were formed near the equator were covered with ice. Okay. And the large duration of the snowball event. The strength of the snowball hypothesis, it is the only hypothesis which explains simultaneously all these paradoxes. Okay. People have come with various other theories or hypotheses, but they explain one of these, not all of them. This is the only hypothesis which explains the existence of cap carbonate, banded iron formation, ice at the equator, and the long duration of the snowball earth. So we have no other theory which competes with the theory proposed by Hoffman and Kirschving. Okay. Now, I would like to point out that this is still a hypothesis with some proxy evidence, because we are talking about events that occurred 600 million years ago. There are error bars in your measurement. Things could go wrong. So one should remember that no theory can be proved beyond any reasonable doubt. Okay. A theory can only be disproved, and longer it survives the attacks against it, the more confidence you can place in it, while never knowing for certain it is right. This is how science operates. Science is not adamant. Science doesn't believe in perfect, what it might call as undeniable truths. It knows that we discover truth through various hypotheses and verified against observations, and as new observations come, one can challenge the truth. Okay. So whether it is Newton's theory of gravitation or Einstein's theory of relativity, all we can say is that all the evidence collected so far don't disprove it. Okay. But we have to be open in our thinking that if new evidence appears, one should be able to abandon this and find a new way to explain. So, the snowball Earth hypothesis is very daring and very unusual, and the 3 or 4 things it postulated have all been supported by some evidence from geological past, but still it is not complete. There could be surprises waiting for us. Okay. So, the reason why I spent so much time on this particular event which occurred long time ago is that you have realized that Earth climate can be quite unstable on account of a combination of ice albedo feedback and greenhouse effect. These work in opposite direction, but they can lead to completely ice free Earth or completely ice covered Earth or anywhere in between. All these possibilities are open, and it has happened in the past. Just because the Earth temperature was very stable between 10,000 years ago and 1850 does not mean Earth climate is stable. This was a wrong notion many people had about 100 years ago. Today we realize that as you look at Earth's past going back to 600 million years ago, that there have been very many dramatic changes in the Earth's climate. They happened in the past, they can happen in the future. Okay? So, that is a lesson from Snowball Earth which we take as we try to understand how the human induced increase in CO2 may change the Earth's climate dramatically in the future. Okay? So, that is the whole purpose of discussing this Snowball Earth event, because it is very rare, happened long time ago, but it has a lot of lessons to tell us about what can happen in the future. So, in the next lecture we will take up a topic which we have not discussed much, which is aerosol. Aerosols are small particles which exist in the atmosphere, which we cannot see, which alter the albedo of the Earth. Okay? And they also play an important role, but they are not as well understood as the greenhouse effect or the effect of ice sheets. Okay? Those are well established, that is why we spend a lot of time on them, but we have to spend at least a lecture on the role of aerosol, which is very complex, because aerosols are not uniformly mixed in the atmosphere. Carbon dioxide, wherever it is released, it reaches everywhere. So, CO2 concentration is fairly uniform from polar to the equator. This is not true about aerosols. Aerosols are very high near the urban areas where we release them, or near deserts where winds kick up huge amount of dust. But in other parts of the world, in polar regions, aerosols are very low. Okay? So, there is a large spatial variation of aerosols on Earth that makes it difficult to understand its role. And secondly, aerosols also vary with season. Okay? So, for example, in Sahara, in summer the aerosol is very high because the air is very dry and the winds kick up the dust. Okay? So, the complexity of aerosol is that it is spatially varies much more than carbon dioxide, and it also varies a lot with season. Okay? So, we will discuss the difficult problem to estimate how the Earth climate is controlled by aerosol in the next lecture. Thank you.